Welcome back to the fifth video about my electronic steering wheel / rudder jog project IP68. The last video I published about that project that was in April 2023, and in that video we finished the static calculations for the whole setup. But today I want to make first chips on that project. Enjoy! Before we start turning stuff on the lathe, a quick look at the almost finished overview drawing. There are some changes in regards to these static calculations and the dimensions of certain parts here compared to what I told you in part 4. Card here, link in the description. Yeah, I made some mistakes here. Respectively, I overlooked some things. Just a quick recap of our parts here. So we have a main POM body here with a big hole through which runs a shaft which is connected to a hub at the front, and then the wheel is connected to the hub. We also have some stop bolts here at the end and a little boss here in the shaft so it can slide through here. And we have an end cap. Finally, we have here a little key in a slot between the hub and the shaft to take up the torque. And here's the first major change. In the static calculations, I said we could get away with an aluminum shaft with a diameter of 12 millimeter. However, at 12 millimeters, we were only able to use here a 4x4 millimeter aluminum key. And we would have to make that key comically large to take up the torque. To solve that problem, I enlarged the diameter of the shaft to 16 millimeters, so we can now use here a 5x5 millimeter key, which will take up the torque easily. So that's the first change. Going for the safe option here. 40 millimeters would have been okay also. Starting with 14 millimeters, you can use 5x5 millimeter keys on shafts according to ISO and DIN. However, I went all out and said, okay, let's do 60 millimeters. Feels better, looks better. The second thing, and that was really a mistake, we calculated these stop bolts here purely by their bending when they clash together, which was wrong. Because in fact the bending doesn't matter much. What matters is the shear force on these bolts where they stick out. And there I did some more calculations and found that our bolt diameter was simply too small to take up the peak shear forces that you can reach here. So I also enlarged them a little bit in diameter. That means the boss at the end was got also a little bit longer, and so on. But we will talk about the details of all the parts when we come to actually making them. That brings us to the part I want to make today, and that's a replacement for that wheel hub I bought because that one is crappy and doesn't fit my purposes. We'll start out with a little round puck of aluminum, 35 millimeters in length and with a already finished diameter of 52 millimeters. And then you have, like on the original, here this flange with 3 holes where the wheel will be attached. And then this extensions shaft here at the end, all a little bit smaller than the original. And of course, through the whole thing goes a 60 millimeter hole for the shaft itself. And then we also have a little cut here for our 5x5 millimeter key. And that's it. The flange at the front has is 7 millimeters thick and has these holes. I already mentioned them. They will be threaded M6 in it, 3 of them. We probably make them in a later video on the round table. And then we go down on the diameter to, I have to move. I don't have that measurement here. Why? My mistake. I added the measurement. We go down here to a diameter of 28 millimeters. And that's it. So in this video, we will turn the whole thing to the correct length and the correct diameters and maybe cut the keyhole here for the key. The aluminum puck is already inside the chuck of the lathe and I already dialed it in. And as you can see, that's not dialed in. That's quite crooked. I mean, we're talking here about 15 hundredths of, eccentricity. Ah. Now, before you accuse me of pure workmanship, I marked here the the high spots in blue and low spots in red. And if we measure across that thing here, you will see that our round stock is not actually that round. So we are here at about 25.25 millimeters between the high spots. And between the low spots, we are at 25.04. So yeah, a good 0.2 of a millimeter eccentricity in the part. So dialing it into 15 hundredths of a millimeter is actually quite good. Just something to be aware of, that round stock is not always really round. First order of the day, let's clean up that face, and I'm using here my new turning tools with carbide inserts. Card here, link in the description to the mailbag. First time at all I'm using carbide insert tools, so if I got the angles wrong here or something, please let me know in the comments. That carbide tool for sure leaves a very nice finish, but I have a little puck here, in the middle, so I will shim up my tool 1/10 of a millimeter. So yeah, we are really on center here with the tool. Yeah, I shimmed it 0.1 millimeters up, and there's still the slightest of pucks here, but I would now have to hundreds of millimeters shims, and I don't have them, so that should be okay. Next, we put a nice center hole here, big, because we can, and we have to drill that at the end with 60 millimeters anyway. Life center is in, and now we turn that down for a length of 23.5 millimeters approximately, down to 28 millimeters in diameter. And that means we have to take off 12 millimeters of material. So quite a lot, but yeah, doable. And I will make a first cut here to the line I marked at approximately 23.5 millimeters. And then I will put with that clamp an improvised stop here for the carriage. So each consecutive cut will be, for the same length, approximately. And when we finish that, we can actually go down to the exact 23 millimeters in depth here by just, facing off again the face until we are at exactly 23 millimeters. So let's put on a stop now, an improvised one. I would love to use my dial gauge, but there's no way I can position that here anywhere. Okay, that should do it. By the way, I'm currently doing 0.25 millimeter cuts because otherwise I get a lot of chatter here at that large radius with that small lathe. But anyway, if we come down to a smaller diameter, maybe I can take deeper cuts. We'll see. So we are down to 28.51, respectively 28.49. So let's call that 28.5. And that basically took forever, to be exact. 47 passes, each cutting off 0.25 millimeters. You do the math. We started at 52 millimeters, so we are spot on. My gear is set up for level 1, so between 100 and 300 RPM spindle speed. Depending on what you dial in here. And if I normally cut with HSS turning tools, I'm between 1 and 2. But with that carbide insert stuff, I went up to almost 500. So let's say instead of 100, 250 RPMs. And if you watch the video closely, the carbide insert really likes that, because otherwise it doesn't make chips. It makes these long things. You saw that in between, when the chips got longer and longer and longer, I always turned up the speed. Another factor here is that our diameter got smaller and smaller and smaller, and the circumference is proportional to the square of the diameter. So yeah, some compensation here. And I have to admit, when we started out at 52 millimeters, my little lathe here really struggled with the 0.25 millimeter cuts. I have to admit that I cheated in regards to the stop here. So I didn't really use it as a mechanical stop. Yeah, it probably worked also a little bit as a mechanical stop, but mainly I used it as a visual reference to see when I was coming down to below 1 millimeter. So if the gap here got really small. And on the first pass, I zeroed here the scale. I have to, I cannot turn it. I have to keep that zero. I zeroed here the scale on my lead screw. So one rotation is 1 millimeter. So I can really replicate the stop position or the end position of a cut quite well. And if you have a look here at the shoulder, yeah, it's almost perfect. It's not completely perfect, but almost perfect. And I'm not sure. Maybe these marks here, maybe these are actually 47 rings, okay, for each pass one. And this is really just the form of the tool. Anyway, I will make one more pass now, cutting off 0.2 millimeters. That should bring us down to 28.1 millimeters. And then we do a finishing cut. That was actually 2 passes, because somewhere along the way something bumped the wheel here and we got back from 0.2 millimeter cut. Can you read that? Probably not. 0.2 millimeter to, I don't know, almost nothing. Don't look at me that way. I'm feeling bad enough as it is. And we're down as planned to 2809, 28.1. Yeah, let's say 28.1. For that last cut, I will cut off 0.5 5 hundredths of a millimeter, and then I will go 5 hundredths beyond my stop, which I will release when I reach the end here, and then I will go outward. So we will hopefully clean up that shoulder here. And we landed at 28.0102 and 2800. Perfect. Anyways, we have to cut down the face once more, because this should be now a little over 23 millimeters. And yeah, I know it's upside down for me too. So we are at 23.84. Oh, let's say, 84, 85. Four passes, 0.2 millimeters each, and we are down to 20. Oh, is that already 23? Looks like it to me. 23.02. I think we leave it at that. The next operation would be to put a 16 millimeter hole through here. And so at least 30 millimeters deep, probably 31 just for good measure. Not quite through. We will take here on that face a few millimeters off at the end, but let's say 31 millimeters. The problem here is that my stock at the end can only extend a little over 30 millimeters. And that's not quite enough, because you see the tip here of a drill obviously doesn't count for the depth. You can only count the depth up the cutting shoulders at the full diameter. And yeah, that's the 16 millimeter drill. This is also far beyond the specs of my little mill here. So we start with 8 millimeters, then 10 millimeters, then 12 millimeters, and from there on in millimeter steps, 13, 14, 15, and finally 16. Okay, let's have some fun with a lot of lube. The good news is we now have a 60 millimeter hole here, and I can verify that by using the broach guide here, which we will use to cut a slot for a shaft key. That thing is a little bit undersized, so 15.9 something millimeters in diameter, and yeah, that's perfect. And it's deep enough, over 30 millimeters, so that's perfect. But it was a chore. So the first 8 millimeter hole, that was quite a lot of material and quite a strain, but doable. Then 10 millimeters was quite easy. 12 millimeters went through like a breeze. And so I decided to jump the 30 millimeters and go to the 14 millimeters right away, which was a mistake. That put quite a strain on the machine. Then 15 millimeters, no problem. And then 16 millimeters, disaster struck. You might have noticed in between that I stalled actually the spindle motor here because of the high torque that was required. But at the 16 millimeters, I also stalled it a little bit, but I was able to recover each and every time. However, towards the very end, and things got really strained here, little wisps of smoke escaped. And at first I thought I'm running too hot and my cutting oil is burning away, but it was a different smell. It was actually had a sweet note to it, and the source was unfortunately not the cutting oil. The source was that wooden plug here, which sits directly on the motor shaft, and that's basically the attachment for the first pulley here for the whole gear assembly. And that thing got actually scorched. Okay, so not beyond, I don't know, this is maybe some wood pressed together with some glue or some epoxy. I have no idea. But it's definitely black here now. It didn't really burn, but yeah, we were really at the edge of destroying the machine, or at least that part. It's easily exchangeable and it's no problem to get spare parts for those Proxon lathe. Now, starting at 12-30 millimeters, I could have reached in here with that tool and widened the diameter. That would have been much less strain on the lathe. However, the philosophy here to use really a 60 millimeter drill to do the hole is that I will use exactly the same drill on the body where the shaft runs through. And since the body is large and rectangular, I cannot really do that on the lathe. I have to drill that hole, and I will drill it with exactly the same drill as I drilled that hole. So hopefully the diameters, if not exactly 60 millimeters, but they will be the same, and that's what's important. Anyway, let's clean up that inside edge here real quick. And the outside edge here too. And finally, let's make that surface here nice and shiny. Don't get me wrong, the finish as it is okay. So yeah, you might feel a little roughness, but yeah, that's probably just imagining. But I like it shiny, so let's do that. There, much better. I will now turn that thing around, we dial it in again, and then we do the other side and maybe that diameter too. It just looks ugly, and when we measured the raw stock, it was at the maximum diameter, 52.2 millimeters, maximum and minimum 51.9 millimeters. So maybe we should uniformly take it down to 51.9. And that's what the other side looks like. Still very oily, and yeah, that's not, you probably can't see that, maybe from the other side. Yeah, that other hole is not quite 16 millimeters. But it will become 16 millimeters as soon as we take some material out of that face here, hopefully. I turned around the part and got it dialed into about, yeah, 100, maybe a little less than 200, so good enough. Now let's get that shoulder down here to 7 millimeters. I'm looking at the drawing. Yeah, 7 millimeters. And before I do that, so we don't get any measurements errors, I will clean up both edges here. We're starting out at 11.6, so 4.6 to take off. Rookie mistake, my compound table collided with the piece. You can see it here. I will adjust my setup and then we continue. That were 22 passes, 0.2 millimeter each, and we're down to, yeah, 1.16 That's 1.16, yeah, 1.17. Okay, so one more pass, 0.1 millimeters, and then I measure again, and then I make a decision. 7.09, so I will make one more pass, a smidgen over 500ths. Oh, 0.73. I think we leave it at that. Oh, 0.74, 0.73. Yeah, 0.73 would be okay. 7.034. It's okay. Last operation with the cutting steel. Yeah, I will now take off, as least as possible from the diameter, just to clean it up and make it nice and round. Nope, that wasn't it quite. Still not quite. Almost. Come on. Yeah, still some spots left. That thing was not very round. But yeah, we measured, I think, 0.3 millimeters. So yeah, let's just continue. I saw that there is still a few spots. No, there's still one spot here. And we've taken off so far 0.175. Okay. Okay. I think we... yeah. That's good enough. I think we got it all. I took off a little under 0.2 millimeters. So we're now at 51.92. That's okay. Let's round off the edges here a little bit and clean off. Yeah, there's a real burr here inside. Yeah, nice. Let's take care of that burr here. And I need to get that thing a little bit, the compound, a little bit more out of the way. Sorry for that. Let's change the perspective if we're at it. Yeah, that's better. Okay. That's it for today. All the lathe operations on the wheel hub. And yeah, we will cut the slot for the key next time. And then there will be a large pause until I set up the round table for putting in 3 holes here, like in the original. And while the original looks a little bit, or is beefier, okay, you have to admit that looks much better. Till next time, bye.